Welcome! In this video we will take some raw data name files and generate a database of names, addresses and word groups that we can use in future videos in our PowerBasic Console Compiler application. To do this we will be using array handling, string manipulation and randomization. In previous videos we had a small file with about 15 data records in it which we were using to actually read through. Now for the kind of videos we're going to be doing in the future, we'll need many more records than 15. So what we're going to do with this video is we're going to write a program to generate a much larger data set. Rather than having to key them all in manually, we're going to get the program to generate random first names, surnames, addresses, telephones, eye color and word group. So how are we going to do this? Now we know that our new file we're going to output is going to have in it all of these columns. So we're going to keep these columns. So we're creating a new program based around the routines we've already created. This one again is going to be a console compiler application. All the variables are going to be dimensioned. We're still going to use true and false. We're going to keep the file handling routines we had earlier, which are up here. The only thing I've added to this file is I've added a little bit of text heading at the top, just to describe what each of the functions inside the library actually does. This is very useful 6 months down the line when you come back to look at a library to know exactly what it does, what functions are held within it. So we're going to create a new library for these random routines. We're going to call it PB random routines. Just a bit straightforward blank library, nothing in it yet. So our main PB main function is going to create the console title. It's going to set the color of the console and it's going to set the location of the console on the screen, just to keep it in the same place every time you run it. We're going to call a new function called generate file, which will take as parameter the constant here, the mylargefile.txt, and it will return either a true or false to say we've either generated a file successfully or we haven't. The new function down here, all we've got set on it so far is the header line. As the file's always going to have the same header line, it doesn't need to be randomized. So there we have the first name, surname, address, telephone, eye color and word group, just as we had before, separated by tab characters. And we're using one of our existing library functions called append to file that will take the file name it's passed and it will push that variable called strHeader into the file. So if we actually ran this now, it would say it's completed. And if we had a look at my large text file, there we have my large file.txt with all the headers in it quite successfully. So far so good. All we have to do now is generate some data. So if the first information we're actually after is first name, what we want to do is generate lots and lots of random first names. So down here we will generate some data. Now if we're going to put a data line out to the system, let's create a variable called strdata as a string variable. It's going to contain all the information we want. Now what we're going to put into it. Now we need the first name, so we'll need to pull the first name from somewhere. We'll call it get first name. So where are we going to get these names from? Now I've downloaded a number of files from the internet and each of these files contains information on one of the columns we're actually after. The first one is first names. Now this contains several thousand records, however there is other information in this file that we're not interested in, so we just want to pull out the first name. So we will create a generic routine which is effectively going to actually give us our first name. Now I've created a skeleton for a generic build array function which we will use to build each of the arrays. So we're going to call fun build array. We're going to give it the array we're actually going to build. We're then going to give it the name of the file we're actually going to read. Now in this case the name of the file we're going to get is this. Now as this is quite a long line, we're going to fold it round just for ease of actually seeing what it's actually doing. The next one is the column number we're interested in. Now if we looked at this, we're after column 1 to column 3. So in the first names it's column 3 we're after. So we're after column 3. So the next parameter will be 3. And it's a CSV file, therefore the delimiter is going to be commas. Now what this will do, this will actually generate an array based on this file, and it will put it into that. Now we're giving the name of the array there. In our generic routine, it's just passed as strArray, so it's a pointer, so it will put information into there. Now, to read that into a file, so we want to read in information from this array. So in here, the first thing we have to do is create a couple of local variables. Again, we'll put our usual try catch in. These will be quite familiar to you by now. Now we know the file name. And if it doesn't work, we'll pass back function is false. Otherwise it's going to be function is true. So we need to read each of these values in. Now as we saw before, the values we're after is we're only really after the third parameter. We're not interested in the first line, but everything else we are. So this is going to be a simple sweep around the file. We've opened the file and we want to read each of the data lines. So let's count how many we're doing. So we're doing a loop in here, a while when loop. So while we have not reached the end of the file, we're going to read the data line. So we're going to read the data line and put the value into a variable called strdata. So strdata will contain the entire first line. For example, this. Now we want to parse that and pull back only the third element of that. So again, it's the parse command. So the value we're after, let's create a little variable called value. This is what we're interested in. And we'll use the parse command we've used in previous videos. And in this case, we know the delimiter because we've passed it in the parameter. And we know the column I'm interested in because we also passed that as well. So this will pick up the value. Now the trick is we want to put it into the array. We want to build the array. Now, at this moment in time, we don't actually know how big the array is going to be. So what we can do is we will create a new variable called max record, and what we want to do is we want to do a file scan, which we used in the previous video. Now you remember the file scan, if we have a look at the help, the file scan will pull in this. Basically it will read our file handle, which is this, since we've already opened that, and it will pass records to a variable of our choice, which is going to be that one. Now this tells us how many records are actually in the file. Now if the record contains 100 data records and a header, that will be 101. So we don't want the header line, so we'll basically make it one less than that. A nice easy way to do that is another command we haven't used yet, is basically to decrement, which means take one away from long max record. Now that will tell us how many data lines there are, and we can then dimension our array. Now our array has already been set up and passed to us, so what we're looking to do is to redimension it with this as the maximum, and it's going to be a string still, which is great. Now we have to know where to put the value in the array. Now since we set a counter up, what we can do is we can use another easy bit of information to increment the counter. So that adds 1 to the counter. So the counter starts off as 0 and goes up to 1. Now we know the first line contains a header, so we're not interested in the header. So from counter equals 1, so the first line. What we'll want to do in that one, basically we iterate the loop. We say we're not interested in the very first record, go to the next one. So this counter will have in it the real counter of the records it's done. Number 1 for the first record, which is the header, number 2 and so on. So when we get this value, we need to put it into the array. So how do we do that? Well, we know the name of the array. Now the array will have an element, we'll just call x for the moment, and we'll say it's equal to the value. Now we just have to know what x is going to be. Now long counter is the record we're reading from the file. Now if we put that in, the first record it would actually add to that array is number 2, because number 1 is a header. So we'll make it 1 less than that. Therefore the first one it goes into the first element of the array, then the next, and the next, and the next. So if we actually compile this, hopefully we have not made any errors. Yes, we have. We haven't actually dimensioned the file name to say what kind of type it is. Always useful to do. You won't get very far without that. So if we try compiling that now, oh, and we didn't put a quantification character in at the end, so it would fold the line round. Once we've got past our errors, and we also didn't say what we're returning from build array, which in this case is a long, because we're passing back a true or a false. So, have we get rid of all the errors now? No, we haven't. What's it moaning about now? Right, okay. We haven't dimensioned this variable, which is what we're outputting. Right, okay, now we'll comment this line out for the moment because we haven't quite got that far in the code. Let's compile. Right, it compiles clean. So, if we ran this now, it would build the array. What we can do, just for the sake of seeing what it's actually doing, what we'll do right at the beginning, we'll say it's building an array, and I think we'll add to that possibly a bit of the file name. Let's let's pass it as a parameter. That's probably a cleaner way of doing it. And we'll say we're building the first name. Just so we can see what it's doing, because some of these routines may be working in very, very large data sets by the time we're finished. So what we're going to do is we're going to throw something out to the console to say we're building an array, and we're going to tell what kind of array we're actually building. So if we tried running that, there we go. Building array, first name, file generated successfully. Now what it's actually done, it's actually read 4,500 records into that array very, very quickly, and then moved on. So we have success. So if that's our first one, what we want to do there is actually to get the first name. Now to get the first name, basically we're wanting a value coming out of that array. So we're wanting a random value. So rather than actually do a first name thing, let's call it something generic. Get array value, and we're passing it the name of the array which contains the values. So we're wanting a random value coming out of that. Now we'll get to this get array value in a moment. Having got that, what we want to do is we want to append to the file we've created earlier this value here and put it out. Now, so once we've got the name, we will then throw it out to the array, and we're only going to get the one record because we're looping around this one at the moment. So let's create our get array value. And we're going to create a new function, and this is going to return a string. So how do we get a random value from this array? Now we know we're passing it by ref, so we'll just put that in. Okay, so we need to get a random value from this array, anywhere between 1 and however big the array is. So what we want to do is use the rnd command. Now if we do a check on the rnd returns a random number, basically anything between two numbers. So we're after that kind of expression. Now we know we want it between 1, but we don't know what the upper value is. Now the upper value is going to be whatever the upper value of that particular array is. Now we've used that one several times before. Ubound will tell us the maximum element in that array. So what this is going to give us is long top is going to get back a random number between 1 and the top of that. So if our function then returns the array plus the random value we've actually got, which is the element of the array, so there we go, a very small function which is going to take one parameter, the name of the array. It will then work out what the top of the array actually is using the ubound. It will get a number between 1 and the top, and it will return the value in the array of that. So if we actually just ran that at the moment, it will churn out one first name into the file. So let's give that a try. Well, it seems to have finished. So if we look at my large file.txt, well, it's done some things. We've appended, we haven't actually cleaned the file. Every time we've ran this, it's just kept appending to the file, but there's our first name. So the first thing we have to do is my large file.txt has to be wiped before we start. So we go back to our routine. This is the one that generates the file. So before we actually append to the file, we will put a try catch. And we will kill off the file name. If it exists. Now if we run that now, runs quite successfully. And if we looked at my large file.txt, it now contains the first name, the surname, the address, and blah, blah, and the first name's quite happily in there. Great. Okay. So we'll do the other columns shortly, but let's assume we want to create more than just one record. We want to create many records. So let's have a look at our generate file. In here we have the header, we kill the file name, and we build the array, which is fine. We will build many arrays, so we'll put some spacing for that. And then we then churn out this to the file. Now effectively we want a loop in here. So let's create a little looping variable. Now how many records do we want? Let's say 100. So we do that. It's going to run round this function 100 times. And if we run that now, it's completed. And if we have a look at my large file.txt, and there we have 100 first names generated quite happily by the system in the blink of an eye. So if that's us sorted out first names, what we want to do now is to build the next column. Now the next column was surname. So we need a file with surnames in it. So if we take the same approach, we will want another array actually created for surnames. I'm going to have a few of these. And in here, we're going to call it surname. The name of our array is going to be different. And I've also created a file which has surnames in it. And here it is. Again, this one's easier because quite happily it only has one column. Unfortunately, the file I found on the internet, it's all uppercase, but we'll use a string handling function to fix that. So the file we're after is called surnames. So we will replace the file name in there. Surnames, there only is one column, and it is comma delimited, so we're after surnames. So the existing functions we've already got should do this quite nicely. It will build a second array called str surnames. It will read the file and build it up quite nicely. So what we'll want next is we want to append to the end of this a tab character, and we will now call our next function, which is the same thing again. We'll give it the array we're after. Now, without writing any other code, these generic getArray function ones should work quite nicely. So if we compile that, run that now quite happily. So it's built the first name and the second name arrays, and it says it's generated a file successfully. And if we have a look at our my large file, there we have the first name and the second name. Again, this is tab delimited quite happily. So the problem is that our surname is all uppercase, which is not quite what we're after. We want something that is the first character uppercase and all the rest lowercase, which would do us nicely. So how do we manage that? Now we know that this is our function that generates the first name. This is a function that generates the second name. So we want to perform something on that. And there's another inbuilt function called mcase, which does exactly what we want. mcase, if you do the F1 on it, you will see that it returns a mixed case version of the string argument, which is excellent. So if we run that now, it runs quite happily, and again very quickly. And if we look at a more large file, there we go. It's sorted out the casing. So we now have random names, 100 of them. So next one to build is we wanted the address. Now the addresses are going to be slightly more complicated because the addresses are actually made up of several, but we can handle it quite happily. So the address is formed up of a number, a street and a city. So we will take the same approach. We want to have a file for streets, and I've created a file containing streets. Again, not particularly epic. And one for cities, same approach again. So what we will do here is we want to build another array, or two arrays. One for streets, and we'll create an array for that. And one for cities. And we called it cities, didn't we? Yes. So you can see the big advantage in creating generic routines. It saves an awful lot of work. So let's create our extra arrays. So these will build our two arrays worth streets and cities. Now, our next task is to create a street number. So, all we really need to do is return a street number. So we want something generic that returns just a random number for streets. So we'll create a function, again a very simple one, called street number. As you can probably guess, this one's going to do something incredibly straightforward along the lines of this. And you can quite easily just do it this way. If we say we're wanting a number between 1 and, let's say 1200. Now that's going to be a number, so we want to return it as a string, so we wrap it in a format. Now that's basically a one-liner, it's not a particularly difficult one. So we go back to our original one here, we put in our fun street number. So that'll be the first bit. Now what we want now after the street number is the street. So this is another get array value. And we're passing the streets array. and we want to add on to that the city. Now we had a comma between the streets and the city, so let's just keep it consistent. We'll put a comma in as the limit between the two, and then we want the same thing that gets us our cities. Right, okay. This is building up quite nicely. If we try running that now, we've missed something. What? Yes, I've spelled cities wrong, haven't I? There we go. There we go. Spelled first name, surname, streets, and cities, and finished. So if we look at my large text file now, there we go. We didn't put a space between the street number and the street name, so that's a little bug we need to fix. But otherwise, it's done it quite nicely. It's put in the street name. It's put in the name of the town or the city quite happily. So if we go back in here and we want to put a space between the street number and the street. So we've got that information in. The other information we wanted in this particular file, we wanted a telephone number. So having put in generic routines to get all the information we want for eye colour, blood group and cities, the only thing left is the telephone numbers. Now we create a generic function to get general telephone numbers. We put that into routines. We don't have to pass any parameters for this one, we're just passing back a string. And if we assume generally that telephone numbers are formed of 3 sets of numbers, city, area and number codes, then we want to use a random routine to pull back the city number. So if we do str city equals, we want a random number between, let's say, 200 and 600. Okay, now that's going to give us back a number, so we want to basically format that as a string. Now it's going to return a number which can either be 1, 2 or 3 characters. So what we want to do is basically add 4 zeros to the front. Now 4 zeros to the front gives us a leading 0 for any telephone number and then 3 other numbers. Now we want in total 4 numbers, so all we have to do is another string function called $. For 4 characters. Now what that will do is it will append both of these strings together, the 4 zeros and however many numbers come out of this between 1 and 3, and then it will take the rightmost 4 characters. And then we do the same for the area. And again for the number, exactly the same approach. So having got that, we want to just tack all of these together. We'll keep it the same format that the original spreadsheet actually had. So we're taking the city plus the area plus the number. Now in the original spreadsheet we had spaces between each of these, so we'll, just for continuity, we'll keep the spaces in. So that should return us a telephone number. So we go back to our original code and we try running that now. There we go. And if we have a look at our text file now, we have indeed got telephone numbers in the system. So we have the first name, the surname, the address, the telephone number, the eye colour and the blood group, all quite successfully sitting in there. And we have 100 records in the system. So, to generate a lot more than 100 records, all we have to do is to change that number. 2000 records. So, what we might want to do is not output something every single record, because that would take too long. Maybe put something out every 500 records. So for that, we can quite happily use a command called mod. So we wouldn't want to output something every single line. So if we put in something like this using the mod command will take one number, divide it by another number, and return what the remainder is. You can use that quite happily to say, well, if the line counter of 1 divided by 500 equals 0, i.e. it's a multiple of 500, then we can print something out. Now we may want something, say, 200. So we should get 10 iterations through the whole thing. So if we try running that now, assuming we actually put the right variable in, it will run quite happily, and it will print out every 200 records it's processing. This way it gives the user, if there is one watching it, some indication that the program is actually doing something and not to panic. There we go. Generated successfully. So now that we have our generated data, which has now got 2,000 records in it, you can create as many dataset records as you actually need. So I think that completes today's video. Thank you for watching.